Hello everyone, and welcome in this module in which we will be discussing about the basic structure of the subject which is taught on the both UG and the PG level in the electrical engineering stream, which is known like very important subject, which is known as the power system analysis. I will be recording this like subject under the your own teacher community. We provide the project guidance and the doubt clearing session on the like on each subject related to UG and the PG. So you can reach out to us for any kind of help on our website. So let us start our discussion on this power system subject. So it is the most important subject related to electrical engineering. If you look into this, like it is the heart of the electrical engineering. So it is taught on the both UG level and the PG level. So if like first we will do what we will be doing like first we will be discussing about the basic structure of the power system, like what will be there in the power system course. So we will be looking like what are the topics which is taught under the power system course. So if we talk about the basic, first we will be talk about the basic of the power system. So if you look into like your surrounding, then you will be found like really a system which will be responsible for the power generation, power transmission, or power distribution. So all these like generation, transmission, and the distribution, this complete system is known as the power system. So every component of this like transmission or generation or distribution is known as the power system. So if you look into your surrounding, then you will be finding most of the like these component like generation or transmission or distribution. So on these components will be discussed under the power system course by like in the systematic way, like how we will be generating the electrical power, how we will be transmitting it from one place to another place, and how we will be distributing it among the like consumers. So these are the things which will be done, and power system analysis is do to improve these performances, like how we can improve the generating performance or transmission performance or distribution performance. So we will be analyzing the all these three systems so that we can improve the power system performance. So first we will be like discussing about the generating power plants. Like generating power plants is known for the generation of the huge bulk electrical powers. So on the generating power plant, there will be like bulk electrical power generation will be there in the generating power plant. So there are lots of kind of power generation. So there like in the power generating system there will be a huge electrical generator. Sometimes it will be like PV cells also that could be also able to generate the electrical power. So most of the electrical power stations use the electrical generator to generate the powers. So there are different kind of electrical power plants, like steam power. In steam power plant, you will be burning the coal and you will be generating the steam from that, and you will be running the turbine from that steam, and your generator will be coupled with that steam, and that steam will be feeding the mechanical power to that generator, and that generator will be converting the mechanical power into the electrical power. So main thing what we'll be doing by this electrical generator, we will be converting the mechanical power into the electrical power. So in the steam power plant, we will be burning the coal and simply generating the steam from that, and we will be running the turbine from that steam, and that uh, elec- uh, turbine will be coupled with your electrical generator, and it will be running by that along with that steam turbine and generating the electrical power. Sometimes we will be having that hydroelectric power plant in which we will be we have some kind of hydro turbines like Kalpan or Pelton, so by which we will be running the our electrical generator. So that hydro power is converted to the electrical power from this hydro power station. So apart from this hydro and the steam, we will be having that wind generator also, by which we can convert the wind energy into the electrical energy. So BIM, a big wind farms are there to convert the big, like absorb the wind energy from the atmosphere and convert it into the electrical power. So wind generator are also there. So there are lots of kind of electrical generating power plants. So some are them are the conventional, some are them are the renewable. So all those things will be covered under this generating power plant. So wind power plant, tidal power plant, or sometimes PV, say solar system. Sometimes it is the ocean wave energy. So these are the covered under the generating power plant. So in the generating power plant, we will be looking into the performance of these power plants, like how they are converting the energy from the mechanical side to electrical side. These analysis are done into the generating power plant stations. So this is the first part of the power system. After that first part, like when you generate the electricity, then you have to transmit that, because it will be generated on some kind of remote location. Then all the power which will be utilized over that cannot be utilized over there. So you have to have some kind of transmission system to transmit the electrical power from one place to another place, because we will be using the electrical power to near to the like urban area. So the transmission system is also a important thing of this. After that power generation, you will be transmitting the power from one place to another place. So in the transmission system, what we will be studying about the modeling of the transmission line. Like if you have some kind of transmission line, then for analysis of that transmission line, you will have to model that into the terms of the mathematical modeling, because you can't analyze any system by just looking into that. You have to model that system so that you can do some kind of analysis over that system. So we will be modeling, first we will be modeling the transmission line on the basis of the length. Like if you have short length transmission line, then we will be modeling that transmission line in like different way. So we will be modeling the transmission line on the basis of their length. So if we have some short transmission line, then we will be modeling it by different way. If we have some medium transmission line, like up to 160, like up to 180 kilometer, we model it as we name it as a short transmission line. So we will be modeling it without like considering the capacitors. So if we have short transmission line, then we will be modeling it in the different way. If we have like medium transmission line from 80 kilometer to 200 kilometer, then it will be modeled in a different way. There are two kind of model for the modeling of the that pi model. One is the medium lines, one is the pi model, and other is the t level t model. So by this model you can analyze the medium transmission line. And if you have a lot transmission line like over 200 kilometer, then you have to analyze it in the different way. So all these modeling will be done in the into the performance of the transmission line. First we will be modeling the transmission line, like we will try to calculate the input output relation of the current and the voltages. So we have some input current and output current into the input side, and output voltage and output current on the receiving end side. So we will be correlating this quantity by some terms which is known as the ABCD parameter of the transmission line, and we will be putting some kind of relation between these two parameters. So apart from this transmission line parameter, like performance of the like modeling of the transmission line, we will be calculating the line parameter. Those ABCD parameter is known as the line parameter. So this is also discussed in the performance of the transmission line. Apart from this, there is another term which is known as the corona, which is also discussed under this performance of the transmission line. So corona is the simply transmission line loss which is happened into the when we transmit the power from one place to another place. So there will be some kind of corona discharge. It is like hissing kind of noise. If you look into high level transmission line, then there will be some kind of hissing noise you have observed from that those transmission line. So that phenomena is known as the corona discharge. So due to that corona discharge, there will be some kind of loss in the transmission line. So we will be analyzing that corona loss also there, so that we get we can get to know how to minimize this corona loss. So these things are covered under the performance of the transmission line. After that, what we have to do, we have to go through the compensation technique. Like if we transmit the power from one place to another place, then there will be some kind of deterioration, like some kind of voltage drop across the line, or some kind of like power losses will be there into the transmission line. So to minimize the deterioration, like voltage regulation you have to minimize, and the power loss you have to minimize, there are several compensation techniques by which you can compensate the voltage and the control current profile over the transmission line. For that, we will be connecting different kind of power system element across the line, so that the voltage and the current profile of the transmission line remain in the same way what we want, like what is our requirement. So in the compensation technique, we will be discussing about all those compensation technique by which we can compensate the line and we get the required performance by the transmission line. So these things will be covered under the compensation technique. After that, we will be, when we transmit the power from one place to another place, from where we can utilize those power, then we will be having the distribution system from that. So in distribution system, what we will be doing, we will be after getting the power from the transmission system, we will be stepping down that power, because the transmission line will be having the large voltage level. Because if we transmit the power on the low voltage level, then there will be like a low power capability of the line, and the losses will be also there on the line. So main reason behind this, like why we transmit the power on the higher level, is that like if you transmit the power on the low voltage level, then the power transfer capability of that line will be very less, and the stability of the line will be very less for the same power. That's why we go for the big high voltage level transmission, and also the losses are also less for the high voltage level. So that's why we go with the high voltage level transmission. So we can't use that high voltage level power in our like daily like appliances. So we have to step down the that power level, so that we can easily use the power in our appliances. So for that, first what we will be doing after the transmission, we will be step down the voltage from the transmission line. We will step down the voltage from the higher voltage level to lower voltage level, and we will have some kind of distribution system, and we will be distributing that power among the like consumers. So in the distribution system, we will be having some kind of small transmission line and transformers and some kind of distribution feeder, so that they distribute the power into the consumer. So in this distribution system, we will be discussing about how can we can improve the distribution system. So after that, after this distribution, we will be discussing about the fault analysis. So fault analysis is like, as the name suggests, fault analysis means if there any problem in the power system which like stop the power system, like it is kind of interruption in the power system. So if there is any kind of fault, then it is covered under the fault analysis. So in the fault analysis, we will be looking about the different kind of faults, which are generally happened into the power system. So we will be looking into that. So there will be a lots of kind of faults. So majorly there are four kind of fault. One is the triple L or symmetrical kind of faults, in which all the three phases, like we know the power system is of the three phases. So if all the three phases are get short circuited, then it is known as the symmetrical three phase fault. So it is very rare kind of fault. So it is one of the fault. After that, three-phase fault, we have LG fault, which is known as the line to ground fault. So if one of the phases among the three phases gets short circuited with the ground, then that is known as the LG fault, or the line to ground fault. So that is covered under to the LG fault. So after this LG fault, we have another fault which is known as the line to line to ground fault. That is double LG fault. So if any two of the phases get short circuited with the ground, then that fault is known as the line to ground fault. So this is known as the like third kind of fault in the power system. And after that, the last fault is known as the line to line fault. So if in the line to ground fault, the two phases get short circuited with the ground. So if the only two phases get short circuited, then that is known as the line to line fault. So that is also comes under the fault analysis. So these are the four faults which are generally happened into the power system. So we have to look into the like characteristic of this fault, like what are the fault current, which fault is more dangerous, which fault is not much dangerous. So these things we have to analyze into the fault analysis, and we have to find out the like pre-fault and the post-fault conditions, what are the post-fault current into the lines and what are the post-fault voltage. So these calculations will be there. And also for doing this calculation, because these are the very tough calculation, if we go with the normal like network theory, then we will be introducing to like one other convention by which we will be easily doing this fault analysis, that is known as the symmetrical component. So if we have any any kind of unbalanced system, if the phase currents or phase voltages or the not balance means like if they are not 120 apart, then we will be using this symmetrical component by which we can easily analyze the unbalanced system. So these symmetrical components will be also introduces into the fault analysis chapter to analyze the fault analysis. So after that fault analysis, there is another important chapter which is known as the load flow analysis. So in the load flow analysis, it is simply like solving the nonlinear equations. So there will be lots of nonlinear equation into the power system. Like if we have a big power system in which there will be lots of buses, and we have to find out the operating condition of those power system, then we will be going with the load flow analysis. So in the load flow analysis, we will be trying to find out the steady state operating condition of the power system. So by this, like in the planning of the power system, it is most important thing which we have to done before the planning the power system, that is load flow analysis. So by the load flow analysis, we will be trying to find out the steady state operating condition of the power system. Suppose you have 2 or 3 bus system which want to do the load flow analysis. So there will be 2 or 3 kind of load flow analysis which is discussed under the power system, by which you can do the load flow analysis. So by those methods, you can find out the steady state operating conditions of the power system. So majorly 2 or 3 load flow analysis which is discussed under the power system course. One is the Newton-Raphson load flow analysis, another is the Gauss-Seidel load flow analysis. Sometimes we use the DC load flow. So majorly 2 are the most important, and there will be some kind of modification in these 2 methods also. But the majorly we use the Gauss-Seidel method, another is the Newton-Raphson load flow method for the load flow analysis. So with that, we will be assuming some kind of pre-operating condition of the power system, and we will be performing various iterations to get the final operating condition of the power system by these methods. So there will be like some kind of operations which we will be doing on the load flow analysis, by which we will be getting the final operating condition. After this load flow analysis, we will be discussing about the power system stability. So suppose if there is any power system and there is some kind of fault in that power system. So if there is some kind of fault in the power system, so maybe that power system may goes into the unstable region, because sometimes you have heard about this term like blackout. So if the system goes into the unstable region, then sometimes the grid fails. The grid from which we are getting the power, that gets failed. So that's why sometimes you have heard about some kind of blackout. So this blackout doesn't happen. For that, we studied about this power system stability. So power system stability, in this we will try to find out the stability of the grid. Is that the grid is how much stable, or when it will become unstable. So these analysis will be done into the power system stability. So in the power system stability, we will be finding out the like operating condition, if the line is operating on this operating condition, then what will be the stability of the line, and what are the different unstable conditions in which the line may go into the unstable region. So in the stability analysis, we will be having the equality area criteria, by which we will be generating the condition for which the system may go into the unstable region. So there are lots of kind of study will be there in the power system stability also. So we will be having like equal area criteria, transient analysis, and all those things will be done into the power system stability. And after that, sometimes there one other chapter is there which is known as the switchgear and the protection. So as the name suggests, it is for the protection of the power system. So we will be using, like in the power system, there are lots of switchgear which is used as a protection of the power system. So the devices which are used as the protection of the power system will be covered under this switchgear and the protection. So switchgear means like there will be some kind of mechanical switch by which we will be opening and closing the power system circuits. So there will be lots of kind of switch gears. So all those switch gear will be covered under this chapter, and every type of protection like which we are generally using into our power system, that is also covered under this power system protection. So switchgear and protection section, it is like analysis of the protection of the complete power system. So after this, we will be having the HVDC system in the recent power system analysis. So HVDC system is known as like in starting we have discussed like transmission are generally the on the AC side, AC level. Like AC power is transmit over the transmission line. So due to some like advantages over the HVDC over the AC transmission, we use sometimes HVDC analysis. So there are some kinds of like uh, predetermined condition, so we go the with the HVDC analysis. So there is a lots of advantage with when we go with the HVDC analysis. So in the HVDC system we will be discussing about the HVDC transmission fact device, like fact device and recent trends in the power system, like what are the recent trends. So this HVDC is itself a recent trend by which we can transmit the power by the high voltage DC transmission, and there is a lots of advantage of the HVDC over the HVAC transmission. So these are like covers the complete power system. This is the topics which are covered under the power system course, and we some like there will be lots of kind of numerical which will be asked in the exams also. So all those things under are covered under the power system course. So apart from this, there is another important thing which is known as the per unit system. So per unit system is a kind of representation of the power system which is used like in all the analysis of the power system. So this is also covered under the this power system analysis. So it will be covered like started the power system course is started with this chapter only, that is per unit system, by which we can convert the like actual quantity into the per unit system. So this per unit system is also very important thing, and it will be having a lots of kind of advantages over the conventional analysis. So by this system we can like do the analysis by very easy methods. So along with that, we go with the some kind of power system transients also. So these are the topics which are covered under the power system course. So let us see the general structure of the power system network. So if you look into this figure, then it is the general structure of the power system network. So you have some kind of GS, which is known as the generating station, which will be generating the bulk electrical power on the 11 kV voltage level. So this is the first part by which where we will be generating the voltage from this generating station, and it will be generated on 11 kV. After that, it will be generated on 11 kV, and we can't, like we can't go with this like 11 kV transmission. So we will have to step up the voltage level from 11 kV to another like higher voltage level. So here you can see like we have stepped up the voltage from 11 kV to 130 kV. And after this stepping up process, we will be having some kind of transmission, like either it will be medium or it will be short kind of transmission line, and we will be transmitting the power over the transmission line. And when this transmission line transmit the power and replace the power from one place to another place, then we will be doing the step down process in which we will be getting the primary distribution level, in which the step up the voltage which is step up to 130 kV, which will be step down to 33 kV. Some these voltage level may be changed due to with the different power system to different power system, because it will be depend upon the geometrical conditions and how long you have to transmit the power and nature of this generating station. So it will be depending upon like voltages level, or depending upon the like what are the general structure of your power system. So I am talking about a simple power system network I am taking. So if you look into this in the primary distribution, you have the 33 kV distribution level, and after that you will be stepping down to 11 kV, and then 11 kV will stepping down it to 415 or 230 volt, and this will be like distributed among the consumers. So this is the like general structure of the power system, and by this which we will be distributing the power from this kind of structure. So after that, in the final end, we will be having our loads, which will be consuming the electrical power, which is generated from this electrical generator. So for that, like analysis of the power system, the most important, like a very important thing, which is known as the single line diagram. So if we have some kind of power system, then we can draw the single line diagram corresponding to that power system. So this is a typical power, like single line diagram, which we have drawn for any kind of power system. So generator are simply shown by this like circle, and the transformer are shown by this like this kind of structure. So if we have some kind of transmission and transmission line, then we can convert the whole power system in this form. And this like vertical lines represent the bus from where the power system, like power is accumulated, and it is also distributed among the different direction. So this is kind of single line diagram by which we will be analyzing the complete power system. So if like these are the components we have already discussed about this, like in a general power system, we will be having the alternator, power transformer, transmission lines, some station transformer, distribution transformer, and the loads. So these are the general components of a general power system. So for doing the power system analysis, we have to model the like components of the power system. So this is the modeling of the synchronous motor, transformer modeling, and after that, like transmission modeling. I have told you, like in the performance line of the line, we will be modeling the transmission line, and after that there is a induction motor modeling. So these are the modeling of the transmission line, and after that what we will be doing, we will be converting the all those actual quantity like voltage or the impedance or the currents into the per unit. So this is the like conversion formula for the impedance per unit conversion. So if you have some kind of like impedance, then you can convert it into the per unit impedance. So for that, you have to find out the base impedance. So base impedance is a quantity. To calculate the per unit impedance, you can calculate the base impedance by this formula. It is simply kVA base whole squared, and you have to divide it by the MVA base or kVA base divided by 1000. So if you have some kind of kV like on 11 kV or 33 kV your power system is working, then you have to choose it as a base kV, and after that you have to find out the base kVA also. So if you get the base kV and the base kV of the power system, then you can calculate the base impedance. And when you divide the base impedance, like actual impedance of any component by this base impedance, then you will be getting the per unit impedance of that component. So this is how we can calculate the per unit impedance, and we can generate, like there are lots of formula, like if you have any old per unit and you want to convert it into the any new kind of per unit system, then you can do it by this conversion formula. So these are the like by which we can come into the per unit system. So if you look into the advantages of the per unit calculation, like over the conventional voltage ohm or ampere like convention, then in the per unit impedance is referred to, I like if we use the per unit system to analyze a power system, then the per unit impedance of a system is if we refer on the either side of a single phase transformer, then it is same. So if you look into the like conventional analysis, in that there you will be having the different impedance on the either side of the transformer. You have to refer it on the primary side or the secondary side as per your convenient, and you will be getting the different kind of impedance. So per unit impedance referred to either side of the transformer is same for the per unit analysis. And the manufacturers, like if you getting some type of component of the power system, then the manufacturers also provide the impedance rating in the per unit. And there will be no difference into the three phase and the single phase in the per unit analysis. And also the calculation become very easy because the per unit will be always will be less than unity or near to unity, so that the calculation is also easy in the per unit impedance. And after that, getting the per unit impedance and all the quantity into the per unit, you have to draw the impedance diagram, that is single line diagram. So this is the kind of single line diagram which is drawn for this network. So this is the single line diagram, and this is the impedance diagram which is drawn for this network. So for analyzing this type of network, you have to find out the single line diagram and the this impedance diagram both. So let us see some kind of numericals which will be there, like this is the general formula to calculate like the y bus of the material, like y bus of any system. So these things will be also covered under the under the power system analysis. So all those like per unit conversion and after that fault analysis, these things will be done under the this power system application. So all those things, there will be lots of kind of numericals also, those will be discussed under this power system analysis. After that, you can see like these are the load flow, and these things also in the fault analysis will be there also in the power system analysis. So that's all from like my side for in this module. Thank you for joining this module. And if you have any doubt regarding like any kind of subject or related to this subject, then you can reach out to us, and we are your own teacher community, and we provide the project guidance and the doubt clearing session related to each and every subject on the UG level and the PG level. So if you have any doubt or you want any help from us, then you can easily reach out to us from on our website, and we will be more than happy to help you. Thank you. Thank you for joining this session.